Hello, we have another forced convection question. So we have a heated cylindrical rod. So there's two ways to do cylindrical rod. You could either do the table or you could use the formula. I have another video on a cylindrical rod where I do both the table and the formula for one question. So if you want to know how to do the table, go watch that video. If I remember, I can link it in the description. Then we have air at 20 degrees C with a velocity of 10 meters per second. So then this will be used to figure out the Reynolds number of the air to see if it's turbulent across this rod or not. So the rod has a diameter of 5 millimeters and an emissivity of 0.95. That means radiation. And then we have surrounding temperature 20 degrees. So the air is the same temperature, both of them are 20 degrees. And the heat flux is 1600 watts per meter squared. And then it says evaluate the air properties at 70 degrees C. So let's work this through step by step to get what we know. So the first step for these forced heat convection problems is calculate the Reynolds number. So that's velocity times the diameter times the kinematic viscosity, divided by the kinematic viscosity. We have all of these. So we have 10 times the diameter of the thing is 5 millimeters, or 0.005 meters. And the kinematic viscosity, that's not given, but we can get that information from a table. So let me grab all of the relevant information from a table. All of these I just read from the table at 70 degrees C. That's what it told me to do. So all of these are just from 70 degrees C. Now we can continue with the kinematic viscosity. 1.995 times 10 to the negative fifth. I'm going to move all of this over here. Great. The next step is to calculate the Nusselt number. So, again, there are two methods to do this. You can see how far off the table method is if you guys want to, but I'm going to use the formula. So the Nusselt number for a cylinder is 0.3 plus 0.62 times the Reynolds number to the 1/2 times the Prandtl number to the 1/3 divided by 1 plus 0.4 divided by the Prandtl number to the 2/3 and then all of this to the 1/4, and then all of this is multiplied by 1 plus 2506 divided by 282,123 zeros, and this is to the 5/8, and this is to the 4/5. So now we can substitute in Reynolds number and Prandtl number. I didn't actually calculate Reynolds number. That's kind of embarrassing. That is 2506. Okay, now the Nusselt number. Let me go calculate that. Alright, so we type all this into our calculator. We get the Nusselt number is 25.73 Great. Now what we can do is we can use the actual definition of Newton's number, which is hg over k. So we have this. That means that Newton's number times k over d is equal to h. 25.73 times k over d. I remember d, and k is 0.02881. So we type all of this into your calculator. We get 148.3 watts per meter squared Kelvin. So that's H. We need to determine the surface temperature of the rod. So we know the total heat flux. They gave it to us. So this is Q dot total. Q dot being the per area version of big Q dot. So we add up all of the tiny Q dots. So that could be from convection and radiation. And we know there's radiation because they told us an emissivity. So we actually have to pay attention to it. So we know that Q dot convection per area is H times Ts minus T infinity. And for radiation, that's these two constants times Ts to the fourth minus T surrounding to the fourth. Great. So the goal is to solve for the surface temperature of the rod. So that's Ts. 1600 is equal to H. We know that. We just calculated it. 148.3 times Ts. We don't know what that is. Minus T infinity. T infinity. That is the air temperature, 20 degrees C. But because there's radiation, I'm going to just keep everything in Kelvin. Alright. Now we need the emissivity and things like that. So what do we have? We have the emissivity of 0.95, and we're not given sigma, but I will give you sigma. So now 0.95 sigma 5.67 times 10 to the negative 8. Ts to the fourth, we don't know what it is, minus T surrounding. That is the same thing as T infinity in this case. So that's going to be 20 plus 273. So we type all this into our calculator. Ts is equal to 395 Kelvin. You subtract 273 from this. That's 122 degrees Celsius. Boom.